Wicked conversion skills between decimal to binary and back. That's what this video is all about. Let's begin. This is the opt-out section for this video. If you are comfortable with the answers, the correct answers to these three questions, I'll see you in the next video. We'll have some fun there. However, if you are not yet comfortable with binary to decimal or decimal to binary conversions, and you've got about 12 minutes, you are in the right place. Let's go. I remember seeing The Wizard of Oz, and near the end, they pull back the curtain to reveal who really is acting as the wizard. And that's what I'd like to do right now with IP version 4. Even though IP version 4, it's represented as dotted decimal. Here we have 4 numbers right here, and they're separated by 3 periods to keep each number separate from the other one. What's really happening is that's just for us humans as a convenience. What's really going on behind the scenes is that each one of these numbers represents 1 byte of data. Now before you freak out and say, a byte of data, it's really just representing each number 8 bits, which go into 1 byte of data. So each of these numbers, 130, 16, 33, and 17, because each number makes up 8 bits, sometimes these numbers are referred to as an octet. And an octet is nothing more than 8 bits that are all represented together in the same grouping. So whether you want to call this first number, the first number, or the first byte, or the first octet, all of those mean the same thing. So the trick is, if we wanted to convert for whatever reason, including the ability to do things like summarization and custom subnetting, we first have to be able to convert these numbers between decimal, which they're shown here, and binary. Or maybe we're given a binary number and we want to convert that back to decimal so we can go ahead and input it, for example, in a router or a computer. Now, the great news for you and I is that in converting, if we needed to convert binary to decimal or decimal to binary, it's really straightforward because in either method we're going to first write out this table. Now, we introduced this table in our video titled Beautiful Binary, so you already know what this table is and how to draw it from memory. If you don't, I strongly encourage you to go back and revisit Beautiful Binary. But that's our starting point. Now the question might come up, well, Keith, what do I do first? Do I do decimal to binary or binary to decimal? Usually, you're going to be given something and you need to convert it to the other. In this case, we have a decimal number that we're going to convert to binary. So we're going to do that one first. And it's really just a game. And I call it the Does It Fit game. And here's how we play it. We take a number, so we're going to first start with 130, and we're going to write it out. And all we need to do is take this very first number on the far left, 128, and ask ourselves the question, does it fit? Does 128 fit into 130? Yes or no? It's a binary question. If the answer is yes, we're going to put a bit on in that position. And we're also going to subtract that value of 128 from the number we're trying to convert. So the remainder of this is 2. 130 minus 128 is 2. So we take that remainder and we play the game again. Does 64 go into 2? No. Well, it might a fraction of the time, but we're looking for, does that number go in an entire time at least once? And if the answer is no, it doesn't, we put a 0 there, okay? How about 32? Does it go into 2? No, it doesn't, so that gets a 0. Does 16 go in? No, it doesn't, that gets a 0. 8, does it go into 2? Nope. How about 4? Nope. And then we get down to 2. Does 2 go into 2? And the answer is yes, it does. It goes in exactly 1 time. So we'll subtract 2 from it, and we are down to 0. So the question is, does 1 go into 0? And the answer is it does not. And so we're going to put a 0 there as well. It's sort of like accounting. If you love accounting with debits and credits, trying to get them to equalize, that's all we're doing here, is we're trying to whittle this number down to 0. Also, if you ever come across a time when the number you're looking at goes in more than once, like 2 times, there's a math problem somewhere. So again, we start on the left and we play the does it go in game, and if it does, we take the remainder and then continue working our way right. So this number right here, 100,00010, is 130 in decimal. So let's do one more together, and then I'm going to have you do your expert exercise with a number on your own. So let's go ahead and clear the page, and let's go ahead and do 16. The game is we want to convert 16 into binary we're going to play the does it fit game. So we're going to write out on our paper 16, the number we're after, and ask ourselves the question, does 128 go in? The answer is no, negative. Does 64 go into 16? No, negative. Does 32 go into 16? It does not. Does 16 go into 16? Woo! The lights go off. Yes, it does fit. So we take that number that we just put in, we subtract that from our number, we take the remainder, and we play the rest of the game. You can't stop playing until you've given all 8 bits in that octet or that byte. So 8 doesn't go into 0, nor does 4, nor does 2, nor does 1. This is our binary number that represents 16. It is 0001, 0000. And that, my friends, is also why, as humans, we input IPv4 addresses as dotted decimal. It saves us a whole bunch of typing. So we're going to input, when we configure routers and devices with IP addresses, we're actually going to put in the value of 16 for that second octet. But what the computer knows, or the router knows, is that this is the binary value of that second octet. So here, my friend, is your expert exercise, your first one for this video. I'd like you to take this number 33, and your mission, which I hope you accept, is to convert 33 into the 8-bit binary number that 33 is representing. So I'd like you to take a moment right now, pause this. Now, if you say, well, Keith, how do I start? What I would encourage you to do is start by writing out this table and then simply writing out 33 and playing the game called Does It Fit? So does 128 go in, does 64 go in, etc., etc. Every time it does go in, you put a 1 and you subtract that value from your number and play the game again, continuing on with the remainder. So go ahead and pause me right now, work out the binary equivalent of the decimal 33, and when you come back, we'll validate what that answer is in binary. So excellent work. I absolutely appreciate you practicing and verifying that you can do this on your own. This is a critical, fundamental skill that we're going to be leveraging inside of our world of IP version 4 custom subnetting. So the game goes like this. 33 is right here. We say, does 128 go into 33? The answer is no. 64 doesn't go in. 32 does. So we're going to put a 1 there. We'll say minus 32, and our remainder is 1. 16 doesn't go, nor does 8, nor does 4, nor does 2, but 1 goes in cleanly one time, and our accountant is happy because we've had a 0 balance at the end, which is how it should be. So the decimal number of 33 is representing our binary number of 001, 00001. If that's the answer that you got, absolutely great job. I've got one more task for you as another expert exercise, and that is this. I'd like you to take 17. That 1 byte of data, and tell me what the equivalent binary number is for 17. Go ahead and pause me and do that now. So I know that some of you have already shortcutted this, which is perfectly fine if you're to that point. But the manual way, which is a great way to start if you're just learning this, is to say, okay, great, the number is 17. 128 doesn't go in, nor does 64, nor does 32, but 16 does. And the remainder is 1. 8 doesn't go, 4 doesn't go, 2 doesn't go, but 1 does. But many of you looked at 17 and said, you know what? I get this. 17 is 116 plus 1 more. All the rest are zeros. I'm done. And as you practice more and more with the converting of decimal to binary, your skills will improve. But it doesn't happen by accident. It happens based on practice doing the conversion. So I'd like you to do one more for me. And I'm going to have you do this entire IP version 4 address on your own. And the number is this, 193.17.95.136. That is the number that I'd like you to convert. And you're going to do it 1 octet, 1 number at a time, converting those to their binary equivalent. If you've joined me for all of these videos in order and you've watched the prior 5 minutes, you should be able to calculate the binary equivalent of each of these numbers completely on your own. Go ahead and pause me now and convert this IP address into its binary equivalent. I want to thank you for taking the time to go through these expert exercises. As you practice more and more, your skills will measurably improve. Now, our next task is, what if we needed to convert a binary number that we're given in binary to decimal. Well, we already had a sneak peek at doing exactly that in our beautiful binary video. It's really, really simple to do. Let's say we're given a binary number of 101001111 as an example. How do we convert that to decimal, the decimal equivalent? Well, the answer is we're going to take everywhere there's a 1, we're going to take that value from the placeholder it's in and simply add them up. So we're going to add up 128 plus 32 more plus 4 plus 2 plus 1. So we can do that longhand, 128 plus 32 plus 4 plus 2 plus 1. 8 plus 2 is 10, plus 4 more is 14, plus 2 more is 16, plus 1 more is 17. There's our 1, there's our 7. Then we have in this column 3 plus 2 plus 1 is 6. And in the hundreds position we have a 1. So that value of this binary number right here is 167. And I put 167 equals 167. I guess that's a little bit redundant. So in converting from binary to decimal, we simply look for the ones and then add up the values of those positions for our equivalent total value. So now it's time for your expert exercise in converting binary to decimal. And what I'd like you to convert is this number right here into decimal. So go ahead and pause me. When you're done, go ahead and resume and we'll confirm our answer. All right, welcome back. Let's see how we did. So for this answer, which we'll call option number A here, we have 64 plus 32 more plus 16 more plus 4 plus 2, and that's it. So if we add all of those up, there's 4, 5, 6, 6 more is 12, plus 4 is 16, plus 2 more is 18, we'll carry the 1, there's an 8. So for the tens position, we have 6 plus 1 more is 7, plus 3 more is 10, plus 1 more is 11, that would be 118. And if that's what you came up with, congratulations. You have the ability to convert from binary into decimal. Now let me give you a couple more that I'd like you to practice with as well. Let's take this one right here. Well, 000000000. I want you to do that one if you would, as well as this one, 1111111, and one more. Let's have you go ahead and do 11110000. And we'll call those A, B, and C. And what I'd like you to do is write out on paper what the decimal equivalent of A, B, and C is. And if you're saying, Keith, I think I've got the A, it's 0, you'd be absolutely right. It might take you a little bit longer for B and C, so go ahead and pause me while you do all three of those, write out your answers, and then click on resume, and we'll compare notes. Okay, welcome back. So let's take this first one, option A first. And option A is 0 plus 0 plus 0 plus 0 plus 0 plus 0. Okay, so A equals 0. Now this next one, we have some more adding to do. So we have 128. And here's what I'd recommend. Don't just do it in your mind. If you're new to this, do it as we have in this video by writing out like 128 plus 64 plus 32, which is what this is all about. So for answer B, it'd be 128 plus 64 more, which is 192, plus 32 more, which is 224, plus 16 more, which is 240, plus 8 more, which is 248, plus 4 more, which is 252, plus 2 more, which is 254, plus 1 more is 255. So B equals 255. And you might say, well, Keith, you did that in your mind. You didn't even write that out. And that's because this is one of those values that you're going to see a lot of 255. And it's just because of raw practice with these numbers that I can do that in my head. Otherwise, I'd be writing it out. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 255. And for answer C, we have 128 plus 64 plus 32 plus 16. And if we add all that up, the long way, the short way, use a calculator, what have you, it's going to end up to be 240. If those are the three values that you got when you did the expert exercise on your own, before we compared notes, my hat's off. If you didn't get these three numbers, I would ask you to go back manually, like we did right here and here, and add them up once again, just to confirm that you're doing the conversion from binary into decimal correctly. Also, the valid range, if you will, for any octet, any number in IP version 4 is going to be between 0 and 255. It can't be any lower than 0, because then we're going into negative numbers, and it can't be any higher than 255. Because in an octet, if every single binary number is on, the maximum it can ever get to is 255. But I also, just with a little caution, also want to point out that 0 through 255 is actually 256 different numbers, because 0 indeed is a value. But the numerical high number you're ever going to see is going to be 255. Our action items for this video are to, number 1, make sure we've practiced the binary to decimal and decimal to binary exercises that I assigned in this video. And secondly, I'd have you go back to the opt-out questions at the beginning. When you can now comfortably answer those questions in the opt-out section for this video, you are ready for the next video. I've had a great time. I sure appreciate you joining me. I hope this has been informative for you, and I'd like to thank you for viewing.